Hi everyone, my name is Dr. Richard Ordonez, and I'm a scientist at the Graphene Microfluidics Lab located at the Naval Information Warfare Center Pacific in Pearl City, Hawaii. So right here, you guys are actually currently in our Graphene Microfluidics Lab, and if we look around the room, we can see we have a bunch of different instrumentation and technologies that allow us to do our research. So coming back up here, we'll have you look at this graphic here, and we work on a variety of different technologies that support the warfighter in many ways, but mainly to make their job easier and to eventually help save lives. The different technologies we work in this lab are wearable tech. We do nanomaterial microelectronics research. We also make RF devices out of exotic materials like liquid metal, and we also work on undersea and space communications. But one of the main materials that we focus on in this lab is graphene. So what is graphene? Graphene is a single carbon, or a single material of carbon stretched out in a honeycomb lattice in which its unique geometry and physical and chemical structure allow it to have very unique properties that can help make devices and is suitable for a variety of applications. Some of those properties are it's currently the strongest and lightest material in the world. Because it's very thin, it's flexible. And I'm going to show you a sample of graphene here. And you can see on the sample holder, you see this little square piece. That's actually a piece of plastic. And on that plastic is graphene. And what you can see is that the graphene is virtually transparent. Even though it's virtually transparent, it actually has amazing properties as it's currently the best conductor in the world. And it also has good thermal properties in which that you could use it to cool devices, and it has a very large optical window. So what I mean is that for sensors like your cell phone devices, like your cameras and whatnot, graphene has a capability to absorb a wide range of the electromagnetic spectrum. But I'm going to show you a little bit over here, and it turns out that graphene is a really good thermal conductor. And we have an ongoing project right now in which we're looking at how graphene can be used to make devices cooler. So as you may know, being that we're in Hawaii, it gets pretty hot often. But at night, when we turn our lights on, it also stays hot in the house. So what we gotta do is we gotta turn on our AC to make it cool in the room. And turns out that if you think about it, in your your condo, your home or whatnot, you have your bodies in there that are producing heat. So right now in this room, I have myself and the cameraman. But if we look at the lights are actually producing heat themselves. So in actuality, there's several people in this room producing heat. So shown here is a quick demo in which we have a standard fluorescent light, like the one that you can buy from like your commercial, Home Depot, City Mill, Target. And then we have a light bulb that's enhanced with graphene. It turns out that when I turn this light on, and after some time, this light bulb will actually get warm, and if I were to try to touch it, I get burned, right? But the bulb on the right that has graphene on it, I can actually touch the bulb, and it's still cool to touch. So what this is actually illustrating is that graphene is doing a really good job of removing the heat from the elements inside this light bulb that's generating light. So what that means is that you can produce, that you can operate this light for a longer time. You don't have to change it as often. And then it actually produces, it's bright longer, and it's more efficient when it comes to energy consumption. So when you think about that, the Department of Navy is really interested in using light bulbs like this in their facilities, and that they can reduce the cost of operating their ACs and their HVAC equipment. So we're going to go back over here, and one of the other cool things you can do with graphene is you can make electronic devices. So remember when I said graphene is one of the best conductors in the world? It's actually really good to make microelectronic devices with graphene. So imagine having transistors that operate faster, longer, are more efficient, and consume less power. So right here I'm showing you is a graphene RF device, and this particular device, you can see kind of in the middle, that little kind of square thing right there, that's called an integrated circuit. And an integrated circuit, it can be best described as a city where electrons live. So imagine having buildings and roads and everything built out of different materials like metals and graphene. So it turns out that there's sophisticated instruments that can actually evaporate the metals, like some of the most exotic and unique metals in the world, such as gold, aluminum, and silver, and you can make this city out of those materials. And this particular device was, if you think about the antennas outside, you guys seen these huge antennas, like, standing outside of boats and ships and, the cell phone towers. Those things are huge. Imagine trying to build one of those. That's really difficult to do. So the goal of this device is actually to miniaturize the antenna into something small like this, so it's more portable and it consumes less energy. So with that, this device, when you blast it with RF energy, you can actually use it as a communication device in which you could, miniaturize your antenna into something very small. So another thing that's really cool about graphene is that you can make your own device at home. So shown here is an illustration of a graphene device that we made, that me and my team made as students at the University of Hawaii at Manoa when we were getting our degrees. So at that time, we had this unique idea in which we wanted to make a flexible, cheap, off-the-shelf, biodegradable transistor. And the way that we made that is that we combined unique materials like honey and liquid metal to make a transistor. So to describe what a transistor is, you can kind of see here, a transistor has a source, drain, and a gate. And what happens is that, imagine like you're flowing water between the source and drain. The gate is actually the faucet, and when you turn it, you can actually allow that charge to move between the source and the drain. And this was a unique story because we actually made this out of honey. And what you see here is that with the commercial off-the-shelf material like honey, you can make a very sophisticated transistor device that's fast, cheap, and you can basically build this at home. So if you want to learn more, Google graphene honey, and you can learn about how you can make this yourself at home. So graphene isn't the only material that is great, like I showed you here today. But there's other materials that have come out recently that, like graphene, can be used in a variety of different applications. And I've shown you today how we use graphene to make next generation sensors and devices for the Navy, but it'll be up to you in the next generation to look at these new materials that are coming out recently. So with that, if you want to learn more, you can contact us at the Naval Information Warfare Center Pacific. You can even come and contact myself, and then look at other opportunities like internship opportunities and things like that you can actually work in the lab with us. Thank you.